Hey guys, welcome back. So what we're looking at today is 4.3, Rational Thinking. So let's go ahead and jump right in. So what we're looking at here is we want to perform the indicated operation and be thoughtful about each step we perform in the procedure. So we're looking at fractions. So sometimes we're adding, sometimes we're multiplying. Now remember, when we add fractions, we have to have a common denominator. So on number 1, we can just add them as is. 8 plus 5 is 13. So our answer would be 13/17. Now, in the case of number 3, we have 4/5 and 7/11. We have to change the denominator. We have to find a common denominator. So common denominator between these would be 55. So 5 times 11 gives us 55. So 4 times 11 is 44. 5 times 11 gives us 55. So 7 times 5 is 35. So we're going to add 44 and 35 together, and we end up with 79/55. All right, now on these bottom 3, we are multiplying. So when we multiply, we don't have to have a common denominator. So 2 times 4 is 8. We just multiply across the top and then across the bottom. And 3 times 5 is 15. There's our answer. Now in 6, 10 times 11 is going to give us 110. And now this one's really big. Now, one thing, before I go any further, one thing that we can do is we can simplify these. So 11 and 33, because they're in opposite places, one's in the numerator, one's in the denominator, we can cancel. The 11 just becomes 1. The 33 becomes 3. Same thing with the 10 and the 15. We can divide them each by 5, so that becomes 2. And then 15 becomes 3. So this makes it a lot easier and much smaller to deal with, rather than having to take 10 times 11 and 33 times 15. Those would get to be some very large numbers. So now it's just 2 times 1 is 2 over 3 times 3 is 9. So 2 9ths instead. Makes it a lot easier. All right. For number 7, explain the procedure for adding 2 fractions when the denominators are the same, when they're different. We just did that. Explain what we did. When they're the same, we just add the numerators. When they're different, we find a common denominator. We'll rewrite the fraction using the common denominator, then add them. Explain the procedure for multiplying. So it's all just kind of explaining what we just did, okay? So you guys should be fine with that. All right. For the next section, fill in the specified features of each rational function, sketch the asymptotes on the graph, and mark the location of the intercepts. So for this section, we have y equals x squared over x plus 6 times x minus 4. We've got this graph right here. The degree of the numerator, well, look at the exponent, it's 2. The degree of the denominator, now right off the bat, you might not recognize it, but these things are being multiplied, so that means it would be 2, because we have an x squared in there. Now, the equation of the horizontal asymptote, so what is it approaching? That would be, so we can look at the graph for that. Horizontal, y equals 1. The vertical asymptotes, we look at the denominator, it's going to be x equals -6 and +4. We can see that here. -6 is this line right here. +4 is this one here. It's approaching but never crossing. The y-intercept, notice, 0, 0. And the x-intercept, well, it's also 0, 0 because that's the only place it actually crosses the x-axis. So this is what we are looking at here. So you can use the graph as well as the equation to help you. For number 12, the numerator has a degree of 1. The denominator has a degree of 2. So degree is your key word for this lesson, degree. The equation for the horizontal asymptote is y equals 0. The vertical asymptote is going to be x equals -3. The the y-intercept is going to be the origin, as we can see up there, which means it's also our x-intercept. Now, on 13, degree of the numerator is 1, degree of the denominator is 2. Equation of the horizontal asymptote, notice it's approaching but not crossing in all places, so it's y equals 0. Vertical asymptotes are x equals -2 and +5, which we can see off the graph, as well as the denominator of the equation. The y-intercept. So the y-intercept is, so it looks like 0, 0. It's actually 0, 1, -1/10. So very close to 0, 0, but not quite. And then the x-intercept, where it crosses the x-axis, is right here at -1, or it's right here at -1, 0. So that one's a little hard because of how zoomed out the graph is. It's not as easy to see those minute details when we're dealing with such small things. But we could see right there, that's where it's crossing. And then you can tell just slightly that it's down below the y-axis, so not quite 0, 0 for the y-intercept. All right, this last part, we are looking at reducing fractions. Reduce the following fractions to lowest form, then explain the mathematics that makes it possible to rewrite the fraction in this new form. So we have 12/15. 12 and 15 are both divisible by 3. So we divide them both by 3, and we're going to end up with 12 divided by 3 is 4, 5 divided by 3, or 15 divided by 3 is 5. So our explanation is just that numerator and denominator have a common factor of 3. This can be, divided out. So same idea for the rest of these. You're just trying to find the common factor. So some of them may not have it. So 26/11 is simplest form. No common factors of 26 and 11. So going through and figuring those out, okay? All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.